All right, in this video, I'm going to solve all of these questions for this log quiz over here. And I'm assuming you have a basic scientific calculator for this one. Some of these questions can be solved without a calculator as well, but some of them are pretty difficult without a calculator. So let's get started with the first one here. I can just turn this into 3 to the power of 4, and then these cancel, and my final answer is just 4 for part A. For part B, I can move the fourth root to the exponent. So it's just going to be 5 to the power of 8 over 4. And then this just cancels. So I'm left with 8 over 4, which is just 2. Third question here, this one's a bit of a difficult one. You can simplify without a calculator, but the steps are a bit long. It's not going to fit here. So I'm just going to use a calculator and my change of base rule here. I'll turn this into log 8 over log 0.25, which is just negative 3 over 2. Part D, we know that this is just the same as log 8 to the power of 0. And my final answer is just 0. Part E, I can just turn this into log 1 over 9, and then I can turn this into 1 over 3 to the negative 1. And then I know that I can make, if I square that, that's log 1 over 9, 1 over 9, and now I'll make the exponent negative half, because if I square root this, it'll turn into 1 over 3. That cancels, and I'm just left with negative 1 over 2 as my solution for that one. This one here, log 8 just cancels, and this left with minus 2, so easy one there. Over here, 3 log 3 also cancels. I'm just left with 17. Over here, I have to move the 3 to my exponent. I have 4, log 4, 9 cubed. I can cancel that, so now I'm left with 9 cubed. And 9 cubed is just 729. This one here, I can multiply all my exponents. So 2 times 3 times negative 4. That's log 2, 8, and negative 24. I can turn this 8 into a 2 cubed now. So log 2, 2 cubed times negative 24. This cancels. So I'm just left with 3 times negative 24, which is just negative 72. Second question, express in log form. So to convert this to log form, I have to log the base of the exponential function on both sides. So I'm doing log g of both sides. And then on this side, these cancel out. So my final answer is just log g q equals s. This one expressed in exponential form. So I'm just taking the base, which is v. I'm doing v to the power of both sides. So v log v cancels. So I'm just left with v to the k equals w. Fourth question, state the restrictions on the variable in each equation. So over here, it's x minus 5 has to be greater than 0, which means x has to be greater than 5. And over here, x minus 8 has to be greater than 0, which means x has to be greater than 8. Since they're both in the same direction, I have to look at the overlapping ones, and the overlapping one is 8. So x has to be greater than 8 for part A in the question. Part B, I have 6 minus x is greater than 0. Negative x greater than negative 6. Divide by negative 1 and flip the sign when you do that. So x has to be less than positive 1. And over here, x plus 1 has to be greater than 0. X has to be greater than negative 1. So basically, x has to be between -1 and +1 for the second one. Question number 5, find the inverse of these functions. So to find the inverse, I start by just flipping my x and my y. And now I have to isolate my y, so I'll add 5. I'll move the log 6 to the other side and it becomes exponential. Then I'll add 4 on the other side. And this is the inverse function. Let's try part B. So flip my x and my y. Oops, let's put that there actually. That's my first step. And I'll multiply the 7 in my next step. Then I'll divide by 3. Then I'll move the 2 over. When I move the 2 over, I have to log base 2 on both sides basically to get rid of this. So that cancels there. So log base 2, 7 over 3x equals -x plus 6. And then I'll continue down over here. I'm going to subtract 6 on the other side. And then, oh, I don't know why I wrote that as an x the whole time. It's a y. Then I'll divide by -1 on both sides. So it becomes negative log 2, 7 over 3x plus 6 equals y, and that's my inverse function for this one. Question number 6, they give us a function and then they tell us to do all the domain range and a couple of other key features and then to sketch the function. First things first is I want to put the function in transformation form, so I'm going to rewrite the exponent as -x plus 4, and then I'm going to factor out the k value from my exponent, -x minus 4 plus 8. So now I'll start answering some of these questions and I'll do my sketch at the same time. Sometimes it's actually better to do the sketch first. So I know that my vertical asymptote for this one is going to be at, oh no, this is an exponential equation. So I have a horizontal asymptote. It's going to be at +8. So I have a horizontal asymptote, y equals 8. And then this function here is exponential growth. I'll find my y-intercept first. So I'll sub in x as 0 and I'll calculate this. So my y-intercept is, I subbed in x as 0 in this equation and I got it as 1, 2, 5, 8, which basically means like it's really, really high, but obviously doesn't fit in this graph. That would have to be extremely low. And then we know that this function here is exponential growth, but there's a reflection in the y-axis. So growth would look like that, but since there's a reflection in the y-axis, it's going to actually look like decay, and the function's going to look like that. There's going to be no x-intercept because we're above the x-axis and we'll never touch it. The function is decreasing everywhere. From left to right, it's going down. The asymptote y equals to 8. Domain is just x is an element of all real numbers. Range y is an element of all real numbers such that y is greater than 8, my asymptote. Then my mapping rule xy just gives me, so it's negative x because my k is -1, then plus 4. Then for y, it's ay, so 2y plus c, which is just 8. And that is my mapping rule for this question. Okay, question number 7 is next. Just 3 more questions in this one, although the 8th one is pretty long. Question number 7, write each as a simplified one-term expression. So for this one, the first thing I'm going to do is I'm going to move the 7 to the exponent to make sure you distribute it for both terms over here. I'll move this 5 to the exponent as well. Then I'll distribute the exponent over here. And then I'll combine all 3 logs. The subtraction means the y5 is on the bottom, and then the addition means the x is on the top. And then I'll just combine like terms here. So x7 times x is x8. y7 divided by y5 is just y squared. And that's my final solution for that first one. The second one here, I'll just distribute this negative into this bracket. Then I'll combine all 3 logs. So 18, the 4 is added, so times 4, and then the 6 is divided, so divided by 3. And I'll just do that in my calculator. 18 times 4 divided by 6. It's just log 12. And then this last one over here, to combine these two into a simplified log, I gotta turn this into log 4. So to turn this into a log 4, I'm just gonna turn this into 2 times 1 first, because that's how you create a log. You use ones. Now I want to have this at the base of log 4, so that's, I'm replacing the 1 with log 4 4 because log 4 is just 1. Then I'll move the 2 to the exponent, so it becomes log 4 squared. 4 squared is just 16. Now if I combine these, I'm just multiplying, so it becomes 16 x, and that is the solution to question number 7. Okay, let's go to question number 8. We have some log equations over here. So in this first one, to isolate the x, I'm just moving the 4 to the other side, so it just becomes 4 to the power of 3 over 2, and you can either do this mentally or using your calculator. You should get an answer of 8. Part B, I'm moving the x to the other side because I need to get rid of the log. So 16 equals x to the power of 2 over 3. And then to isolate the x, when I move the 2 over 3 to the other side, it just becomes 3 over 2. I'll put that in my calculator and I just get x equals 64 for the second one. Third one over here, I'll start by dividing by 4 on both sides. Now 55 divided by 4 is 13.75, so I'll write that as a decimal because it's exact, but if it's not exact, make sure you use fractions. Next, I'll log both sides and bring my exponent down. And then I'll divide both sides by log 7, and then I'll put this in my calculator, and the question says to round to 3 decimal places if necessary, so I will put that in my calculator and round to 3 decimal places, and I get 1.35, because the next term will just be a 0. Next one here, I gotta combine these two logs. So log 2x minus 4 over x equals 3. Then I'll move the base to the other side. So x minus 4 over x equals 2 cubed. X minus 4 over x equals 8. Continue over here. I'll cross multiply the x to the other side. So x minus 4 equals 8x. I'll subtract the x. So negative 4 equals to 7x. Then divide by 7. So negative 4 over 7 equals x is my final solution for that one. This next one here, I have pluses in my exponent, so I'll actually start by splitting into 6 to the x times 6 to the 1 plus 6 to the x times 6 to the 2 equals 7. I just split that up using my rules of exponents. Then I'm going to common factor out a 6 to the x. I'm just left with 6 to the 1 plus 6 to the 2. Then I'll do this in my calculator. That's just 42. I'll divide both sides by 42. 6 to the x equals, I think that's 1 over 6. Yep, it is. And then I don't even need a calculator for this because I can go 6 to the x equals 6 to the negative 1, x equals negative 1. So most of these questions are kind of solvable without a calculator. There's a few exceptions here and there, but most of them can be show up in a non-calculator exam as well. For this next one, I'll start by moving the 15 to the other side. So x squared minus 2x equals 15 to the exponent of 1. Oh no, actually, there's an easier way to do this. I'll actually convert the square root into an exponent of half first, because it makes it a bit easier to solve. Then I'll bring the exponent down. Yeah, it makes it a lot easier to solve. Then I'll just multiply by 2 on both sides. So this cancels off, that cancels off. Then I'll move the 15 to the other side. So 15 to the power of 1 is just 15. Move the 15 over to this side. This is just a quadratic equation. I can factor it. My two possible solutions are 5 and negative 3, but I have to check to make sure that they're both good solutions. So they both have to be greater than 0. 5 squared is 25. 25 minus 10. 5 is good. So that gives me positive 15. Negative 3 squared is 9, plus 6 is also 15. So both these solutions are good. They both work, so we do have two solutions in this question. Next one over here, so I have log x, log 327 equals 32. So there's a lot over here. I guess I can start by simplifying that exponent there because I know that's very easy to simplify. I can turn that 27 into a 3 cubed. So now this all cancels. Log x cubed equals 32. And then I could either bring the exponent down or I could move the log to the other side. I'll just move the log to the other side. So actually, now I'll bring the exponent down first. I think that's better. 3 log x. I guess the numbers might be too big for my calculator. Otherwise, I'll divide both sides by 3. So log x equals 32 over 3. And then I'll just move the log to the other side. So 10 to the power of 32 over 3. Which is a huge, huge number. So I think I'll just leave it like that because Don't want to write down this number with so many decimal places. And let's go to part H, last one over here. So I think we can make 0.125 and 4 into the same base of 2. So I'm just going to start by writing 0.125 as 1 over 8 to the power of 5x. And this I'll write it the same for now. So now I know I can make them a common base of 2. So I know that I can rewrite this as 1 over 2 cubed 5x equals 2 square 2x minus 1. And then I can turn this into 2 to the negative 3 5x. I just move that to the top, made the exponent negative. And over here it's 2 to the 4x minus 2. So then I can just cancel the bases. Negative 3 times 5 is negative 15x equals 4x minus 2. I'll subtract the 4x, so negative 19x equals negative 2. Divide by negative 19 on both sides, x equals 2 over 19 is my solution to that one. Then last question here, it kind of printed off the page, but I'll rewrite it over here. So we have f of x equals log base 2 to the power of x, g of x equals this quadratic equation. We need to find the domain of f of g of x. So f of g of x, I'll just start by writing that function over here. That's just f of x squared, 2x squared plus 4x minus 70, which is just log base 2x squared plus 4x minus 70. So to determine the domain of a log function, we got to make sure that the base, whatever's inside the equation, the log equation, basically has to be greater than 0. So we're solving for 2x squared plus 4x minus 70 has to be greater than 0. To solve this, we got to just factor this first. That's a simple trinomial with 7 and negative 5. So here x equals negative 7, x equals to 5. So we know that this is just over here a quadratic equation with intercepts at negative 7 and positive 5, and it's a positive 1. So it opens up negative 7, 5. We know that this is greater than 0 over here in this interval and over here in this interval. So my domain for this log function is x is an element of all real numbers such that x is less than negative 7 or x is greater than 5. And that concludes this quiz. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.